Greetings, this is Artie from Artifact Electronics. In this episode we're going to have a look at my auxiliary workbench. For those of you who watched previous episodes on the TRS-80 Model 1, you should already be familiar with that workbench, and somebody commented a while ago and said, why don't you get that pinball machine running? Well, the pinball machine, full disclosure, it was basically working before I put it, or I conscribed it to be an auxiliary workbench and covered up the top of it. But thought that was a really good suggestion, and what I'm going to do is free the machine, clean up all the junk off of it, and then we will have a look at the anatomy of a pinball machine. Alright then, it took a while, but she is unearthed. Not too bad a shape actually. The art's still good with minimal dings. Back glass is perfect on it. And you got a captive audience right on top of it. The playfield is also pretty good. I mean, it had been in use. I bought this machine like 25 years ago, so got it on a farm somewhere around here. But playfield's not too bad. The only problem right now is that the rubber rings around the flippers seem to have decided to petrify and crack apart. So before we play anything, we obviously have to fix that. But I fished out the power cord, plugged her in, and let's give it a try. The power switch is located underneath the machine on the right side. No things like soft power switches or anything. It's a push button, and the entire machine power is running through that push button. So let's see what happens. It's actually a toggle switch. Now this takes a while because it's running a power on self-test. Oh, I saw something. Well, it's powered up. One other thing I can see is on the display on the lower left. It looks like it's missing the least significant digit there. But the battery on the board still seems to be good because it's remembering the high score from the last time I got a high score on it. And I think we should get started by lifting the hood. First having a look under the playfield, and of course fixing those pesky rubbers so later on we can actually play a game. Alright, to get inside we unlock the coin door. Then we need to remove this, which is called the lockdown bar. Oh, what a pain to do this one-handed. And then we slide off the playfield glass. And right there, we run into a problem. And that is, I got a shelf and it won't let the glass slide out. And there's still a good amount of glass in the channel, so I think I'm just going to have to manhandle the machine a little bit to create enough clearance here to remove this glass, and I'm going to do that off camera. So I finally got the glass off without breaking anything, including the glass itself. Without the glass on it, there's a lot less glare, and we can have another look at the playfield, which really doesn't look too bad because these playfields usually wear pretty badly. They'll wear down to bare wood after repeated play, and it looks like I must have saved this machine just in time. I mean, there are a lot of marks on the playfield and darkening and stuff like that, but if you find one that's been in service until now or until recently, it won't look like this. So let's raise the hood finally. The playfield's up and it's held in place by its little prop rod there. You will notice that power is still on. If you're doing this at home, turn off power before sticking your hands in there. I've been playing with these things for a really long time, and well, I wish I could say I know where not to stick my hand. I still get a little jolt once in a while. The solenoid voltage in here runs, I don't remember, it's like 50 volts or maybe that's the later machines, but it's enough to give you a bit of a jolt if you stick your finger in the wrong place. But this is the mechanical part, and starting from here we can see the ball trough over here. This is a single ball machine, so it just detects when the ball falls into the trough. It closes a switch here. And flipper mechanisms. Again, when you press the button, it just supplies power to the solenoid, which proceeds to pull back and make the flipper swing up. Same thing over there. And everything else is also affected by solenoids. The slingshots that kick the ball back. The drop target assembly that basically, when you hit a drop target, a spring pulls it down, but then when the drop target needs to be reset, the solenoid pulls up the whole bank and latches it into place. There's some pop bumper solenoids there, and that's pretty much everything that's going on. We got the lamps running on 6.3 volts AC. That's why, compared to lights you see nowadays, they look kind of dim. And a lot of people replace these with LEDs. Put a rectifier in there and run them off LEDs, but I like to have my stuff look as original as possible, so I'm going to leave the shitty dim lights in there. It's got a flipper fuse down here just for the solenoids, for the flipper solenoids if they start shorting out. Can't see any other fuses down here, but that pretty much sums up the mechanical part of this. It's just a matter of switches detecting ball movement and solenoids doing things that are triggered from inside. Nothing very special there. Looking at the bottom of the machine, the cabinet is nice and empty. A hi-fi speaker in there. Now, who can tell me what that green solenoid in there does? That is basically your free game indicator. So when you reach a certain score or you get over a special rollover, the thing kicks the cabinet and it makes a really loud knocking sound, and that's how you know that you just got a free game. And let's see what else over there. We have all the little devices that make sure that you don't mishandle the machine too much. This ball here, whenever you slam the machine, will roll up, and if it rolls all the way to the end, it completes a circuit and you'll get a slam tilt. Don't fall down, light. Don't shine me in the face either. So let's put this down here. In the middle of the picture is the tilt mechanism, and the way that works, you just got a pendulum here, and if you shake the machine too much, the pendulum will make contact with the ring around it and cause a tilt. And finally, we have the that is also a slam switch over here, but the way this is oriented is it'll detect if people lift the machine, such when as a ball is draining and they want to prevent the ball from draining, people will just lift the machine, the front of the machine, so the ball rolls back into play. Well, this will prevent you lifting it, and but if this doesn't come out, if you just drop the machine or lift it slightly or let it fall down, this switch will close. It's also a slam switch, and that'll also tilt the machine. Other than that, a collection of parts in there. We have the coin door with the coin mechanisms, and yeah, that about sums it up on the lower part of the machine. And now let's go look at the electronics that make it sing. To get to the electronics, we got to unlock the back box, put that key over there, lift the glass out of its channel and remove from the machine, and that'll give us access to the cover on the back box cover that protects or covers the electronics. So let's open that up. Here's what it looks like after I lifted the glass, and looky here, the last digit came back. So it was definitely a bad connector problem. Another thing I see though is I cycled power on it, and the high score seemed to have reset itself to 0. So I guess I was wrong. There probably isn't a battery in there. It just showed a random value. And I should have known anyway that that wasn't a true high score, because the minimum amount of points you can achieve on this game is 10 points. And if you remember, the high score actually showed a non-zero in the least significant display. So that was just some random score, random SRAM state it came up in. But hey, looks like the digit is fixed. So now we'll open this, and we'll see the electronics in all their beauty. So basically the display connectors look like that, and they tend not to make real good contact or corrode after a while, but I guess just so you can kind of see the 0 from behind. It's behaving now. Oh well. So we're done with that. So first we have the MPU board over here, and it's driven by a Motorola 6800, not 68,000 but 6800, which is sitting up here. We have a bunch of ROMs. As you can see, there's space for a lot of ROMs, starting from the top over here and going all the way down here. But let's see, this one is stuffed with a 2732 and a 2716, so all that was needed for those was the 2 slots. One of the pains is you got to strap these things for the proper EEPROMs, because they basically gave you a whole bunch of choices of what to put where, and that's what those yellow wires you see are doing there. Let's see what else we have. Let's move the light over a little bit, but we have minuscule amounts of RAM over here and here. And yes, there is no battery. There is a battery supposed to be here. It's an iCat battery, and one of the first things you learn when you get these machines is cut that battery out, because when it starts leaking, it'll leak usually on the board below it, which is the lamp driver, and wreak havoc with that. Other than that, it's got 2 parallel ports, 6821s here and here, a boatload of dip switches to set the options, and that's about everything there is. It's just a 6800 running the basic processing code. Next to it we have the power driver board, which is multifunction, It generates the voltages necessary. There's a 5-volt regulator in the big heatsink over here. It generates the 190 volts required for the displays to light up. And then basically it's got a bunch of power transistors that ground their respective solenoids so that they fire. And that's really the power regulator board, or the power board, that does all of those tasks. Below the MPU board we have the lamp driver board, and that just has a bunch of SCRs on it and some demultiplexers. And the demultiplexers just select which light on the current cycle to turn on, and because they are driven by SCRs, they basically turn off once there's no control signal going to them anymore. So the code has to continually refresh the lights that are supposed to be on. And that's how that works. No latches over there. Well, yeah, I guess the SCR acts as a temporary latch, but that way everything gets refreshed continuously. And that's why the lamps are also driven by AC, and I don't know how well the camera showed it, but they do flicker a bit, and that's why. And lastly, we have the soundboard over there, and it creates the bleeps and blops that you heard. Now, one thing I need to add, which I haven't said before, is this machine is vintage in 1978 or thereabouts. It was the first generation of solid-state pinball electronics. So this was the first commercial foray from Bally into completely digitizing the control circuitry. And what else is there? Oh, we have in the corner, we have a transformer and some rectifiers sitting on top of it. Those generally, the connectors on there coming out, these were under-spec pretty badly, and the connectors usually burned up very quickly. But then again, you know, keep in mind this machine's 40 years old. It did require some work when I got it, even 20-some years ago. But I don't think they were ever intended to last this long. The idea was, let's make a machine. The operator makes their money back in, what, a month or so? And then it's gravy after that, and people get bored with the machine, and we'll sell them a new machine, and this one can go to the landfill. Little did they know that there's a lot of people out there who like to keep these things running, and they're not that hard to keep running, but they do need maintenance. Back to the display board. You can see that the bulbs in there are all wired in parallel, and that's because that's the general illumination. It's not computer driven, but it's basically on all the time. And I guess they decided to wire it like that. Somebody sat there with a stapler and a big ass soldering iron and made all of those tracks. The displays, of course, are fed by the actual signals coming off the CPU board. And other than that, there's some instructions in here on how to set up the dip switches and other information. And that's it for the electronics in here. I wish something was broken so I could show you how to fix it, but as you can see, nothing's broken. Well, other than the display, but that was a display problem, which is also pretty common in these machines, that the displays, either the solder joints crack. That is also common because you usually put a lot of force on these when you're inserting those large connectors, or of course the pins of the connector themselves become corroded, and you see what I saw a little bit ago. So remember, I said all of those lights, or most of the lights in the back box, are general illumination, which means they're not computer controlled but powered all the time. But you can see those blinking lights. They're also GI, but they have a special type of light bulb in there. And the way that works is basically when the light comes on, the contacts on the actual bulb heat up and separate. And once they separate, they cool down again, make contact again, and that's why the blinking interval is not very predictable on them, or the length of the on-off cycle. But that's what you can plug that into any of the general illumination bulbs, and they will blink on their own without needing computer control. Now, differently, the two bulbs above, those two that just blinked, those are under computer control, and you can see they're not as nearly as bright as the general illumination ones, because those are driven off they receive DC. Well, no, actually that's not true. They receive AC also from the lamp driver board. Our last digit is still working. So now there are some test modes here. And you get into the test modes by pressing that button in the coin door. And one of the test modes is the lamp tester. Okay, so now you can see all the computer controlled lights blinking. That's the lamp test mode. Also on the playfield, even though you can barely see it on the playfield, because you can kind of see the bonus ball light blink, but in the lamp test, everything is just overwhelmed with the general illumination, which is what lights the playfield all the time. The next test is the display test. And it'll just cycle through all of the digits, which now clearly shows us that we're good on the displays. And the next test, I think we'll test all of the solenoids. I'll show you the solenoid that it's testing. Next is the sound test. After that, you can remember there were a whole bunch of dip switches on the board. Well, some options get set by those dip switches, but there's a bunch more options that you can set in here by stepping through, by repeatedly pressing the test button. So I think what this does is the credit display, which is this one, shows you the parameter number, and then the displays show you the actual value assigned to that parameter. I think if you hit the credit button, yeah, I think this one sets the free game score 1 up. So by repeatedly pressing the credit button, you can change that. Then you step up to parameter 2, which I think is the second free game score, and so on and so forth. And that pretty much sums up what this machine does. One more thing I should show you is the power on self-test on this, which was one of the earliest consumer machines I've seen that actually performed that. See, right in the middle of the view, there's a green LED that isn't lit, of course. And what happens is when I turn on power, you see that LED starts blinking. So that was 7 times, I believe. And the way that thing works is if all the tests pass, it tests the RAM, it tests the ROM checksum, see if it can talk to the PIO chips, and a few other things. See if it's getting an AC signal, because it uses that for timing. And if all of that is good, it'll do its blinks. Then you can hear the startup tune, and the game will power up. Now, if something is wrong, it basically stops at that test. So you turn it on, it can't communicate with the 6821s, it'll just stop there. So the way you use that is, since there's no digital displays or anything on there, is you have to count the number of blinks. And so if it stops at 4 blinks and doesn't continue, you look up in the manual, what does that mean? And that'll guide you towards what was wrong. So if we look at the manual, and let's see if I can find the part where it tells you see right here, LED on module A4 flashes 7 times. No. See symptom number 1, page 15. And here they don't even tell you what they mean. All they tell you over here is that it must flash 7 times, otherwise you should start replacing parts. There is a section here somewhere that actually tells you. That's probably in the service manual, which I don't have handy right now. But let's say you look it up in the service manual, it'll clearly tell you, hey, if this thing blinks 4 times and then goes to sleep, you got, for instance, a bad SRAM. And then you know where to look to fix that problem. I almost forgot the petrified flipper rings. Remember I said these machines do need maintenance. If you have one of these or plan on getting one of these, you need to maintain a stock of parts. At a minimum, a bunch of light bulbs and pin rings. So I dug up this box, which conveniently says pin rings on it. And wouldn't you know, there's rings lying right on top of it. So what I'm going to do is take out a couple of these red rings and put them on the flippers. And then put things back together and see how well she plays. Figured it might be mildly amusing to see the solenoid test run from underneath the playfield. See, there's the lamp test. See how dim they are? You can see them from underneath, but they're really dim. That's the display test. What fun is that? Alright, let's play. Keep in mind that the dip switches and the settings I haven't really set up, because in order to do that I actually have to read the manual, and that's not a good thing. Also not going to replace the battery for now. Well, without a battery I can spend 10-15 minutes resetting this thing, and then when I turn it off everything's gone. I'm not going to replace the battery right now because I don't this is probably going to revert back to an auxiliary bench, sad as that may sound, and I don't really want a battery in there. Okay, here we go. I haven't put the glass back on either, just in case something decides to act up and I have to help out the mechanics in here. Gave me a free gift of 20,000. Counting down the bonus at the end of the ball. Oh no, this light here. I saw it flash on, so that's probably a bad contact in there, or a dirty contact. So let's have a look at that real quick. There you go. It's in there kind of loose. Probably have to do some work on the socket itself. But that's really where the second box of parts comes in, where you should have replacement light bulbs. I noticed that there are 1 or 2 light bulbs that aren't lighting up correctly, so anyway, let's extra balls lid here. Oh! Oh, I didn't even have to do that. I have an extra ball, so I'll just let it drain. And I get my free ball. Isn't this fun? That's what you have to do when you have a glass on it. I only need Miss September over here. It didn't hit her. Oh, the light's burned out. Oh well. Nice score, thank you. Well, I hope this gave you some insight into how pinball machines work. This was one of the most basic ones, obviously, 40 years old, first digital implementation. The ones before this were entirely electromechanical with lots of relays in there. And then, of course, after this, things just progressed as the microprocessor technology kept getting more and more powerful. So I hope you had at least half as much fun with this as I did. Please support the channel. If you like this, give it a thumbs up. If you want to see different kinds of pinball machines, the anatomies of different kind of pinball machines, let me know in the comments. Or leave me a comment anyway. And make sure to subscribe. Playboy thanks you. And so do I.